Hello everybody, today we are going to be going over problem number 5. We're going to use statdisk. I will be sure to state my hypothesis and then discussing my findings from each one. Alright, so I'm going to go over here, number 5. Alright, a local college requires an English composition course for all freshmen. This year they are evaluating a new online version of the course. A random sample of n equals 16 freshmen is selected and all of the students are placed in the online course. At the end of the semester, all freshmen take the same English composition exam. The average score of the sample is M equals 76. For the general population of freshmen who took the traditional lecture class, the exam scores form a normal distribution with a mean of mu equals 80. All right, so from the question itself, I'll move over to statdisk. I already have it in here just to make it easier. We get the n equals 16. The m is equal to 76, as well mu is equal to 80. And then from going back to part A, if final exam scores for the population have a standard deviation of 12, does the sample provide enough evidence to conclude that the new online course is significantly different from the traditional class? And we're going to use that with a significance of 0.05. So there we have our significant region is 0.05 and the standard deviation is going to be 12. So we are going to go into analysis with hypothesis testing, and we're going to do a mean one sample test. So we're going to keep that the population mean is not equal to the claimed mean. The significance is good at 0.05. Our claimed mean in this situation is 80. And the population standard deviation is going to be 12. Our sample size of n is 16. The sample mean is 76, and we do not have a sample standard deviation. We're going to click evaluate, and here we are given our alternative hypothesis is mu not equal to the null hypothesis. So our null hypothesis in this situation is that our average exam score is 80, or that there is no significant difference between the online and the traditional class. So in this case, our null hypothesis is mu equal to 80, and our alternate hypothesis is going to be that our exam score is not equal to 80, or that mu does not equal 80. We are given that our test statistic is z equal to negative 1.33, with our critical z being plus or minus 1.96. From this, our test statistic is within our critical region, or technically not within our critical region, which indicates that our sample mean is not extreme or unusual from our population with a mu equal to 80. Therefore, that we are going to fail to reject our null hypothesis, being that mu is not equal to 80. So then we move on to part B. If the population standard deviation is 6, is the sample sufficient to demonstrate a significant difference? And we have the same critical region. So the only difference that we're going to make here is that our standard deviation is going to change from 12 to 6. And we're going to evaluate this. And in this part, our test statistic is negative 2.67, which we see does fall within our critical region. And given that, if that indicates that our sample mean of m equal to 76 is extreme or unusual given the population with a mu equal to 80, therefore we reject our null hypothesis that mu is equal to 80, and the data does not provide evidence to support the claim that the average score is 80. And then we're going to move on to part C. Compare your answers for parts A and B and explain how the magnitude of the standard deviation influences the outcome of the hypothesis test. So from part A, the z-value corresponds to the standard deviation equal to 12 is negative 1.33. In this test, we fail to reject that null hypothesis. And from part B, the z-value corresponding to standard deviation is 6, or the standard deviation of 6 is negative 2.67. and in this test we reject the null hypothesis. Given this information, we can conclude that as the standard deviation increases and hence the standard error increasing, this reduces the likelihood of rejecting the null hypothesis. So that is all of the answers for part number 5. Thank you very much.